Good morning students. Welcome you all for this video lecture. Now I am going to present the topic of n-queens problem using backtracking algorithm. Myself C. Usharani, working as an assistant professor in AADS department from Ramco Institute of Technology at Rajapalli. Before we are getting into this topic, we want to know what is n-queens problem. It is nothing but we are placing the n number of queens in chessboard. For example, n value is 4 means place the 4 number of queens in 4 cross 4 chessboard. Suppose n value is 8 means place the 8 number of queens in 8 cross 8 chessboard respectively. Here I am going to explain this problem by using backtracking algorithm. In this slide, I gave the definition of backtracking algorithm. Backtracking algorithm is general algorithm for finding the solution to the one specific computational problem and try to give the all possible solution. From that, we will choose one best solution for our problem. It is the most important tool for solving constraint satisfaction problem such as 4 queens problem, 8 queens problem, crossword, Sudoku and many other puzzles. This backtracking algorithm is a form of recursive algorithm because this algorithm is repeated recursively until we will reach the final state. But the main difference between backtracking and recursive is recursive function solves the particular problem by calling a recursive function itself. But backtracking algorithm is eliminate the every step of choices that cannot give us the solution. The n-queens problem is the type of constraint satisfaction problem in artificial intelligence because it contains some constraints while solving the particular problem. Here I am going to take 4 queens problem as the example and place the 4 queens on 4 cross 4 chessboard. So no 2 queens attack each other. Usually, 3 types of problems in backtracking, such as decision problem, optimization problem, and enumeration problem. Both the decision problem and the enumeration problem can search for feasible solution, but optimization problem will search for best solution. So this 4 queens problem will comes under the optimization problem because it will provide the best solution among the all possible solution. In 4 queens problem, following 4 constraints need to be satisfied. Number 1, 2 queens are not in the same row. Second one, 2 queens are not in the same column. Third one, 2 queens are not in the same diagonal. And last one, all the rows and columns must have a one queen. So these are all the 4 constraints. Next we are going to see how 4 cross 4 queens problem will solve. First, we will consider 4 cross 4 chessboard and initially we will fix the row and column value will be the 0. So, we have to place the queen in board 0 and 0. It's shown in the figure. In chessboard, all the 4 previous constraints is satisfied means we will increment the column value by 1. If it is not satisfied, we will increment the row value by 1. When R value equal to 0 and C value equal to 0, so check both 0 and 0. It is safe mode. So now increment the column by 1. In step 1, R value equal to 0 and C value equal to 1. So check both 0 and 1. It is unsafe mode because one row contains 2 queens. So we will increment the row value by 1 and move on to the next step. In step 2, R value and C value will be 1 and check the board 1 and 1 value. It is also unsafe mode because two queens in the same diagonal. So we will increment the row value by 1. In step 3, R value is true and C value will be the same. So check 211 position. This position is satisfied all the constraints. So we will fix the queen in 211 position and increment the column value by 1. And one more important point is when we are placed the queens in board, we have to reset the row value as 0. This is most important. In step 4, R value is 0 and C value is true. So check the board 0 and true value. It is also unsafe mode because already 0th row contains the 1 queens. So increment the row value by 1. In step 5, R value equal to 1 and C value equal to 2. So check the board 1 and 2 position. It is unsafe mode because two queens are in the same diagonal. So we will increment the row value by 1. In step 6, R value equal to 2 and C value is also true. So check both 2, 1, 2 position. It is also unsafe mode. So we will increment the row value by 1 because two queens in the same row. It's shown in the figure. In step 7, R value equal to 3 and C value is 2. So check 3 and 2 position. It is unsafe mode because two queens in the same diagonal. Here we have reached the last value as 3. There is no position. So we have to backtrack and remove the last placed queen in the 2 and 1 position. It can be done in the step 3. And we will increment the row value by 1. It also shown in the figure. Next in step 8, row value equal to 3 and column value equal to 1. So check both 3 and 1 position. It is safe mode because it satisfied all the 4 constraints. So we will increment the column value by 1. It's shown in figure. In step 9, row value equal to 0 and C value equal to 2. So check the board 0 and 2 position. It is in unsafe mode because two queens in the same row. So we will increment the row by 1. Next R value equal to 1 and C value equal to 2. So check the position 1 and 2. It is constraints all the constraints. So we will increment the column value by 1. Next, step 11. Here R value equal to 0 and C value equal to 3. So check the board 0 and 3 position. It is unsafe mode because two queens in same row and same diagonal also. So it is unsafe mode. It's shown in the figure. So next we will increment the row by 1. Next R value 1 and C value equal to 3. Here two queens in the same row. So we will increment the row by 1. Here the R value equal to 2 and C value equal to 3. So check the 2 and 3 position. It is unsafe mode because two queens in the same diagonal. In next step, R value and C value will be 3. So check 3 and 3 position. It is unsafe mode. So we will increment the row by 1. And two queens in the same row. So again we have to backtrack and remove the last position inserted in the queen in the board 1 and 2. Okay, it can be done in the step 10. Next we will fix the R value equal to 2 and C value equal to 2. Check 2 and 2 position. It is unsafe mode because two queens in the same diagonal. So increment the row value by 1. Here R value equal to 3 and C value equal to 2. So check the board 3 and 2. It is unsafe mode. So we will increment the row by 1. And we will remove the 3 and 1 position done in the step 8 and also remove the 0 and 0 value in the initial step because there is no row to increment. In step 17, row value equal to 1 and C value equal to 0. Here we will start with initial position. It is in safe mode, so we will increment the column by 1. In step 18, row value and C value equal to 1. It is unsafe mode because 2 queens in the same row, so we will increment the row by 1. Here R value equal to 2 and C value equal to 1. So check the position 2 and 1. Here the 2 queens in the same diagonal. So we will increment the row by 1. In step 20, row value equal to 3 and C value equal to 1. It is in safe mode because it satisfies all the constraint problems. And now we will increment the column by 1. It's shown in the figure. In step 21, R value equal to 0 and C value equal to 2. So check 0 and 2 position. It is safe mode. So now increment the column by 1. In step 22, R value equal to 0 and C value equal to 3. So check 0 and 3. It is unsafe mode. So we will increment the row by 1 because 2 queens are in the same row. In step 23, R value equal to 1 and C value equal to 3. So check the board 1 and 3. It is the unsafe mode because 2 queens in the same diagonal. So we will increment the row by 1. It can be shown in figure. In last step, row value equal to 2 and C value equal to 3. It is safe mode. So we will reach our goal. Here all fixed queens are satisfied all the 4 constraints and we have reached our goal. So in this way the 4 queens problem can be solved. And this is the matrix representation of 4 queens problem. The empty space is represented by 0 and queen space is represented by 1. And next we will move on to the coding part of n queens problem using backtracking algorithm. It is implemented by using Python language. First we will define the n value as 4. And next define the print solution function. Here for I value in the range of 0 to n, that is here we have to fix 0 to 3 because we are solving the 4 queens problem. So I value is 0 to 3 and j value is 0 to 3 and print the value of ij until ij value will reach the high position of 3. And define the isSafe function with 3 parameters such as board, row and column. In this function, check the row on left side and check the upper diagonal and lower diagonal. If we satisfy all the conditions, it returns the true value, otherwise it returns the false value. And next, define the solve NQUtil function with 2 parameters board and column. Here, try to place the queens in all the rows one by one. If queen cannot placed in the any row, it returns the false value. Otherwise, it returns the true value. And this function, it solved the NQ problem using backtracking. It mainly uses the solve NQUtil to solve the problem. And it returns the false value if Q cannot be placed. Otherwise, it returns the true value. And next we will define solve NQ function. In this function we have to represent the matrix, that is 4 cross 4 matrix. If solve NQ util board of 0 equal to false means we have to print solution does not exist. Otherwise, we will print the feasible solution and return the true value. So this is the coding part of n queens problem. Suppose you want to 4 queens, define the n value as 4, and if you want to solve the 8 queens problem means define the 8 value equal to n value equal to 8. Up to this we have seen 4 queens problem. The same procedure is also applicable for 8 queens problem, 12 queens and 16 queens also. So I hope this is useful. Thank you all.